Okay, thanks again for being here. I think we're all ready. And today, our two very special guests, Advaita and Agnesh. I'm very happy to have you here, guys, because you are a great example of how the fellowship works. So Advaita and Agnesh are currently working in Nimbus, but as I hinted in the description, they started their work as EPF fellows. They've been one of the few lucky people who ended up getting their position at Nimbus even during the fellowship itself. So during the fellowship, they work on the libraries for Nimbus for Verkle. Correct me if I'm wrong. I think I remember it right. But yeah, I mean, I'm curious how the journey was for you and what are you working on right now. Today, they grew to be mentors, like from one fellowship to another, from fellow to a mentor who now can mentor you on the work on Nimbus. So I'm curious what kind of work is happening on Nimbus, what the current fellows might help with, and yeah, to share your journey. So again, thank you so much for being here. I guess you have the presentation or something to share. So the stage is yours.
Yeah, hi. Hi, my name is Agnish Ghosh. I'm from Kolkata, India, and currently I'm working as a software developer in US. Yeah, we call it Ethereum core developer. Um, yeah. We actually don't have any presentation because we were really very worked up. But I have some plans to walk you through the projects in detail, and you can definitely DM me on Discord if you have any questions regarding um, Nimbus ETH2 projects in general. But more about it's like how would you want me to start? Like, would you want me to start about the projects or the journey? Which one would you guys prefer first? Because I really want it to be a very open, interactive discussion so that whatever I say is clear to you, whatever I receive is clear to me. Um, the
Yeah,
journey, everybody wants to listen the journey first.
yeah.
Okay.
That sounds great. Yeah, I was hoping that you have some space to present and then we can ask you anything. But I guess yeah, give us the context, tell us about the whole journey, and I think that makes sense to
Okay.
see your progress, your journey up to the current state of the things. Yeah.
Uh, okay. We can divide the time. Yeah. So I was a permissionless participant. I would start with that. I never got in formally. So how it started is okay. So like before contributing to core development, I was mostly like working with a lot of smart contracts related to DeFi. Um, Even did some work in dApps,
When you're
but
ready.
primarily I did some really good industry grade machine learning research in large language models and NLP before. I did it for about a year and a half almost. And then Advaita, I met him like at the end of 2022, and we actually like just caught up on LinkedIn very randomly, and just very randomly. And what happened is we were like thinking of building a very naive ZK rollup layer 2. I know it's like kind of a bit red in Ethereum L1 calls, but yeah, what we did is we just wanted to understand how things work, how ZK works in general, and for that we just wanted to hack out something like barely working. Okay. And we enrolled in this thing called build space. I don't know if you guys have heard build space nights and weekends. Yeah. um, uh, did he want to speak? Sorry. Oh, okay. We can take questions later. So yeah, so Advaita and I, we went to build space nights and weekends, and we were hacking out a project, and they called us to Dubai. Yeah, and that's like the first time I went to Dubai as well. And we were working on the project there also, and that is the first time I heard of EPF. And I heard like this is a way out where you can like join in work on protocol, and you can basically solve Ethereum's current L1 challenges and all these things. Um, I totally underestimated myself. Okay, like I knew I wouldn't get in. Okay, like there was no surety. The first thing I heard about, like I read about EPF and I told Advaita is that, bro, maybe next year, not this year, definitely not this year. Okay, and Advaita had previously interned at Nethermind, so he had more experience. He really had more experience than me, and what happened is I kind of like I kind of filled up the form at the very last moment, because even I was thinking that definitely I'm not getting in, and I didn't get any interview call because yeah, I didn't have like a very rich background in Web3, even nothing compared to what Advaita had. And but I was interested, like I was really interested, and I was really persistent that okay, like these things are interesting. And the best thing that I found out is all the information, it's maybe a bit hard to find when you're starting off with, but they are really very very organized. I actually saw like there was a previous officer from Tim Waco, and he actually like yeah, he was talking about the governance. And if you grasp that properly, you would realize that every piece of information is properly discussed with the community, is properly cross checked, and we do a lot of dev nets, we do a lot of testing before we go to mainnet. So like very systematic channelization of information, I would say, uh, like in any organization or in any company in comparison. Yeah. So I was getting like I was kind of going with the flows, like what is PM, like Ethereum's PM, or like execution specs, Beacon API, what happens, how are these things working? Okay, like how many passes are there, what to do if somebody raises a PR. If somebody raises a PR, is that a new feature? Do you want to work on it? Is it an experimental feature? How to come across these things? And I realized if you give it some time, it would be really clear to you, the information too. And I saw that I was actually exploring a lot of projects initially for about 3 weeks or so, until I stumbled upon Verkle. And I realized that this is one project which needs implementations almost for every client, because the Verkle's cryptography and the Verkle tree itself are very kind of fused together. If you want to detach it, and if you want to, let's say your cryptography is in another language and you want to FFI, you would probably have to pay a boundary cost across the FFI, and there are more caveats to it. But in itself, what I realized is Verkle is something that needs to be implemented for most clients, and Nimbus was one of them. This is point number one. Point number two is I came across this repository called Constantine. Wait, I can just share the links quickly. Yeah, Constantine. It's basically a general purpose cryptography library that is written in NIM, and we are still building it. It's like there are still things that are not audited and buggy, but um, it benchmarks pretty well in comparison to a lot of Rust cryptography libraries out there. Especially like if you look at, let's say, all the blob related cryptography, all the KZG related cryptography, not PeerDAS, not the latest ones. It's pretty much the fastest in Constantine. There is nothing, there is no cryptographic engine that is faster than Constantine in terms of handling blob cryptography and KZG commitments. So yeah, so I came across this, and I was like, I was basically just going around people that I'm interested in Verkle. Is your client working on Verkle? I went to Bezu and I went to Nimbus. and Bezu had actually, like, they've been working on it, so they were kind of in the process. They had people like aligned to their team, but Nimbus was completely fresh, and they were like, if you join, if you work, you have to write it from scratch. You have to write the tree from scratch. You have to write cryptography from scratch. We didn't even have like the curves for Verkle, so everything is implemented in NIM from scratch. Advaita and I, both of us, we worked on it, and it was kind of, I wouldn't say, see, I wouldn't say like, oh, ECC, or let's say the cryptography that we're using in Verkle, or in general, let's say what we use in ZK Snarks, it isn't super difficult if you have like a math background in like high school or college. Uh, Polynomials, interpolation, all of these things. Yeah, Advaita has a blog. Yeah, we are actually kind of around 67% faster than any other Verkle cryptography library at this point. Recently, there has been a rigorous audit, and we actually kind of found out a bug, but actually that's been fixed too. So we are just kind of right now reworking on the tests with this new feed, like, mm, bug fixes. Yeah, and yeah. So um, he has a question.
I don't intend to interrupt you. Sorry for that, but I have a question. You said you made optimizations like you made like the Constantine library is like 61% faster than any other library. Um, what would you say is the killing shot for that bigger gap between other libraries? Like, are there algorithmic optimizations, or are there like some specific things
Okay,
required
okay.
for it to be fast? What is it? Like.
Okay, a few of it is, let's say, leveraged because we are writing it in NIM. Because NIM's code generator is C, and if you're compiling it using CLang, then and there you save a lot of time. Firstly, there, but this is not actually like most of the optimization. I think Advaita would can take on.
Yeah, so for this much of a difference, the main thing, there are different layers of optimization that are implemented in Constantine, for which it is 67% faster. At the base layer, for x86 devices, very optimized assembly is written for elliptic curve operations. So it gives us a huge leverage above other libraries. It is still slow in ARM-based devices, Constantine, but we are on the way to add those ARM optimizations. But for now, in x86, it is the fastest. So because of those assembly level optimizations, that gives us a big boost. The second layer that comes is the NIM language in itself. So how NIM language works is, if you write anything in NIM and then if you compile it, it spits out uh, a C language, like a C code. But then isn't it a transpiler? No, it is not a transpiler, because the C code that it spits out is not humanly reliable. It's very, very highly optimized code. So if you open that C file, you won't be understanding anything. It's just uh, messy. So because of this, there's another level of optimizations, and C in itself, and it uses GCC or C line at the end of the day to run. So it's very, very fast. And now coming to the cryptography, if you want to dive deeper into all the optimizations that is done, you can refer my blog post that I've sent in the chat. But mainly, there has been an optimization with pre-computed tables. So if you do some square root operations in an elliptic curve point, it generally uses ternary shanks, which is the currently the standard, but it is actually slow in Vorkal, or the cars that we are using, we need to deserialize the point as it will be getting sent over the network. So we need to receive the serialized point and deserialize it and use it in our system. That becomes a huge bottleneck, and especially when a huge amount of point we want to deserialize. So that was solved by a pre-compute uh, algorithm. If you want to read about the pre-compute algorithm, like discussing this in a meeting would be a huge long. It's a paper. It's linked there. It was by, if I'm not wrong, Paul Ashtarkar in November 21, and there was also a Twitter discussion regarding this, how to pull this implementation, like this concept in an implementation approach. That's also linked there. Let me share that too. Oh,
Yeah.
that would be helpful for you guys.
Apart from that, actually, like Verkle uses IPA, and in IPA we are basically recursively breaking down the polynomial size. Uh, so one thing, like a very typical thing that every other implementation did is, I don't know why, but everyone has used kind of dynamically allocated vectors. In our entire Verkle implementation, I think we have like around two dynamic arrays only. Everything is static, everything is defined at compile time. We even for serialization, deserialization, we exactly know the byte array lengths, like, and they're all like kind of defined at compile time. So there is no like check as of like in itself. If you're talking about, let's say, round trip tests, deserialize serialize comes in very handy. Yeah, exactly. There is like, exactly. So let's say scalar field is 253 bits in Banderwagon, and if you try to like kind of deserialize something that is even 254 bit, it gives you a compile time error. So there is no way that you can get past the system. So it actually helps for even for auditing, actually. Yeah. So yeah, coming back to the journey. Yeah, and we had about 4 months, out of which now I have already like pretty much spent 3 weeks, and like 3 months and yeah, a few days, to basically like ship something that works. And we actually kind of took another month, but if you ask us, like, in a total of 5 months, we pretty much finished writing the tree, like not the complete stateless tree, but most of the important operations that were being used in the devnet at that time, Costinin. And we had finished a bare bone, pretty optimized version of the cryptography library as well. If you see it right now, you might see that a lot of things have been moved around because Constantine is actually pushing for its first release in the next few weeks. And yeah, and like post the release, we actually plan to get a few things formally audited. So yeah, if you'll see a few things moved around, but the POC was written by us. And looking at that, at that time, Nimbus's like team lead was Sahari, and Sahari is no longer working at Nimbus, or like he's kind of associated, but he's directly not operating at Nimbus. He reached out to us, and he wanted to hire us, saying that okay, you've worked well. And I think from our cohort, like, I guess another guy got into Lighthouse, and I'm not sure about the others. But as far as I know, three of us actually ended up in as core contributors. So my takeaway is from my basic takeaway from EPF is kind of simple. That is, pick up projects that you can finish. Pick up projects that you won't finish too early. Now, I'm not saying don't pick up those projects. Like, you can utilize your time better. You can do something more. You can, yeah, um, yeah. That is one of the things. The other thing may be a bit subtle, but like say If there is something not in the project list, you can definitely go ahead and contribute, but you may not know its priority. So it might be shipped 3 weeks later or 2 weeks later from now, and maybe somebody who's working full time is working on it, and you want to contribute in between. I'm not saying you don't go ahead. If that person is asking you not to contribute, maybe, yeah, you get it right. So, um, plus the thing is, see, this thing is probably not in the project ideas. Definitely not in the project ideas. So that is something you need to be careful about. Um, because like there has been instances where like people want to contribute, but then they again go to some other project and then they back this out, and this person is left hanging. He doesn't really know if there is an external contributor or not. So a lot of questions there. Yeah, so after that I got like, oops, how much did, okay, okay, just few seconds. Okay, thank you. Yeah, so what I was saying is, yeah, pick up projects from the project list first. Like that should be a first priority. The second thing is, if you want to work on something more, um, do check out the timeline. I guess Tim Waco, or in general, you would get an idea reading Ethereum consensus specs or the latest releases of consensus specs, that how prioritized are the things that you want to work on. If the things are like at a 2 week deadline or at a 3 week deadline, let's say something is going at DevNet, let's say a 5 days, 6 days later, definitely you can't just go and ask the core contributor that can I contribute. I mean, you can if the person says yes, only then. Otherwise, it'll be more like you're like having a conversation within 5 days. You need to catch up. You need to write. You need to get it merged. So yeah, try to do some things, like try to work on projects that have a very realistic deadline, even in terms of of EPF. Then you can actually like kind of maximize your hiring chances if you like wish to continue as a code developer. So yeah, I mean, so around in Octoberish, not October actually, November, we went to Istanbul for Dev Connect. And post Dev Connect, I got like a text from Zahari that he wants to hire, and I sat for 3 more rounds of interview. Advaita went for 3 more rounds of interview as well, and then at around mid-December, I got my offer letter from Nimbus. Yeah, so that is pretty much the story. Um, I would say the biggest blockers that come between you and you getting hired is, maybe you want to end up working in a lot of projects but effectively don't end up contributing anywhere. That is one issue that you can have. And that is one. Most of the times these things happen. Otherwise, it's mostly a thing of persistence. I have seen few people like lose momentum, gain momentum back. Try to be very consistent with your work. Try to give in the hours that you've committed for EPF at like mostly at any cost. So yeah, I mean those are pretty much the hacks. It's kind of not very complicated. It's a matter of luck too. So you need to consider that as well. Yeah, that is most of the journey. Yeah.
Yeah, so he kind of like elaborated majority of that. I just want to add maybe my part of the starting journey. So I was not generally from ML. I started with Web3 only, uh, typical smart contracts and all that stuff. But from day one, I always wanted to know how the protocol works. But as majority of the people, the issue was the resources, what to study. It was too complicated back then for me to understand. And but I kept on working what I could, what I understood. And then yeah, I heard about EPF, so I thought, okay, maybe I can. And but by before joining EPF, I since I interned with Nethermind, I already had a better idea of how the get code base was, how Nethermind, like how a client is structured, etc. Uh, Back there, I also worked on some ZK projects, so I kind of had a decent enough background in understanding zero knowledge proofs and maths. uh, and since EPF started, like even before joining or even before I was accepted, I saw that Nimbus has a posting, okay, Vorkal, and I kind of Googled every project ideas that there was, uh, and okay, do both of you know each other before joining EPF? Yes, yes, we do know each other from before joining EPF. So yeah, where uh, I was going through the project ideas, and I realized like something that I already know is cryptography, and something that I know a little of is the client architecture, and Vorkel would be kind of in between. So I can leverage my like knowledge in cryptography and contribute to the Vorkel, whereas integrating with the client, uh, something I can figure out, at least something which didn't seem very alienated. So yeah, went with that. And first month was completely studying about the cryptography and everything. And one thing I realized, and I want to add for everyone who would be working in any kind of cryptography or something like that, like the theoretical part is obviously needed. You have to go through the theory, how the maths is, and etc. But if you want to look at any kind of cryptographic protocol implementation, then the implementation point of view is very different. So you need to also understand uh, everything, like how some things might be very simple in theory, but the implementation has to is very different, because there are a lot of optimizations and there are a lot of security considerations that we have to keep in mind. For example, Constantine, the library, the name comes from Constantine. So all of the protocols that is in Constantine is resistant from timing attacks. So these kind of considerations are very important when you are dealing with cryptography. You cannot afford to uh, compromise on the security on the implementations that you are doing. Thankfully, during our time, Emrat Sim is his GitHub handle. His full name is Mami. So he kind of was constantly reviewing our peers and guiding us with all the resources. He was also one of our mentors during the EPF, and that quite of helped a lot of it, because writing code in a constant time manner is a bit hard. It's a bit messy sometimes. Also, you have to think of the algorithm in such a manner that it always takes uh, constant time. There are no edge cases. There are no breaks in between. So yeah, that's their first month was all studying and all this stuff. Then we had a call with Zahari, the Nimbus team lead back then, and we set up meetings that how we want to proceed ahead. So there was weekly calls with EPF, like you guys have, where you share your weekly updates, and we also had another call with Nimbus, where we shared our update from what we did and cleared our doubts if we needed any kind of help, all that. And that meeting Mami also joined, so that kind of helped us scope out how to manage the cryptography, what resources we need to study. After, I guess in by the end of second or the starting of third month, we kind of finished the basic implementations of cryptography, like the Banderwagon implementation was done, and then we kind of divided the work. Agnish will be in the Nimbus meeting. We divided the work that Agnish will be doing all the stuff for IPA and the commitments. I will be working on the tree, a bit of the tree implementation and optimizing all the things that is currently slow. So yeah, this kind of division was there. There were also two other fellows uh, who were also contributing, but not as much as us. But yeah, there were two other fellows in the project, God's Power and Naman. God's Power kind of contributed some Sage scripts to Constantine, and Naman, I guess, wrote few purging algorithms in Workle. But yeah, so yeah, kind of one thing I want to add here is like if you are going for a big projects and a lot of fellows are there, having a coordination in between the fellows is really important. So kind of set up calls as much as possible, be coordinated so that like there is no miscommunication and someone might be working on something, your works don't overlap, and at the end of the cohort your work has to come together to complete the project. So yeah, be coordinated. And taking big projects is like what worked for us. Like Workil was huge back then. Like we had to implement all the cryptography from the scratch, then the tree implementation, and then adding the cryptography to the tree, uh, then adding the tree to the Nimbus client. So yeah, uh, it was like I think one of the biggest project in my view that got pulled off. But yeah, that was the journey for building. And I guess after that, we went for Dev Connect, the EPF day, where we presented our developments. But it was not complete back then. But after the cohort ended, we kept on contributing. We didn't stop our contributions because we kind of felt like that. Okay, we started this work and like we started this from scratch, so we were kind of attached to it. So yeah, we kept contributing, and Zahari then reached out to us that, oh hey, we would be happy to have you on the team, and then the standard interview process, and after that we joined. So yeah, that was my journey. Uh, how can someone get started with contributing to client repositories, as most of them seem too overwhelming to start with? Yes. So my suggestion would be, don't try to understand the whole code base at once. If you are working on a feature, try to understand a specific part that you would be working in. Isolate that. First, try to understand that. If you want to understand the whole code base at one go, you will be overwhelmed. You will be like the tendency would be to, okay, I don't understand. Let's leave this. But if you try to isolate the feature that you are working on, okay, for this feature I need to maybe understand the networking part. So you go and deep dive into the P2P part only. So a client has different segments. You can isolate them kind of. So you don't have to understand the code base at one go, but rather take it on a feature by feature request. Like for my case also, even I don't understand the complete Nimbus code base right now. Also, it's been just few months we joined. So the whole code base, no, I don't understand. But yeah, with time, as I'm working on the features, I'm getting to know majority of the code parts of the code base. Yeah.
Yeah, I would just add that this is something which applies to the whole Ethereum. Like people, the core developers that we talk, that you meet, they are expert in their area of the code base or and Ethereum in general. So it's execution
Hmm.
client and this part of the execution client. Sure, like if you work longer in the client, you have overview and you can solve issues in the various things. But mostly the work is divided there. That's why we encourage you guys to focus on one part, one specific feature. Guys, do you want to continue? Do you have more you want to share, or can we start with some
Yeah,
questions?
I want to just add a
Go ahead.
suggestion. What that would be for all the fellows, uh, like joining the ACD calls, all code devs calls, because understanding the part of the governance is one of the more major important things. So yeah, please do join that. Don't miss it. Even if you don't understand anything, just be there, listen to them, and if you have some questions, like it's don't maybe not ask in the ACD call, but later in Discord or reach out to someone. Hey, this was getting discussed. What was it actually? Or maybe can I have some resources regarding this? And like that would be like the greatest thing for you guys to do, because you will be learning what's coming in the roadmap of Ethereum, what are the future upgrades, and what exactly the current work is going on. Yeah, I think. That would be all for my side, and I'm open to questions.
Okay, awesome. Thank you so much to both of you for sharing all of that. It's amazing. Yeah, thank you guys. I think it's a great journey. I think it's great what you shared. I just want to highlight a few things here again. Like, um, it's amazing that these guys worked together as a team. They mentioned there've been multiple people at this team, but it's I think it's one of the great examples of how collaboration of not being one man project, but being able to pull resources, talk to each other can really help in the EPF shipping. So that's one highlight that I wanted to mention, but also and like huge kudos for this, but you guys learning friggin' nim, like it's amazing. You I
Mhm.
think so you haven't had experience with it before, right? I mean, nobody has, right? Like it's a very very niche thing, and you managed
Yeah.
to just learn it from scratch. You managed to implement cryptography from scratch, so that shows a lot of dedication, guys. Yeah.
Yeah.
So yeah, I wanted to just
Um,
highlight that, like, people, even if you don't have like experience in a certain language, like with enough dedication, like you can definitely learn and get up to speed. And yeah, and what Agnes said in the beginning, like even as permissionless follows, like if you keep going, if you keep working, people will recognize your work. Yeah. So, folks, if you have any questions, like write in the chat or raise your hands. I will start with one question that I kind of started there. Like, what was it like with the NIM specifically? Like, what are some maybe tips for learning NIM? What was the journey for you? What are some niches to know about when diving into Nimbus? And yeah, meanwhile, folks, like feel free to raise your hands, ask some questions.
Yeah, well, for NIM, I would say what our approach was initially. We tried to learn NIM like how anyone learns a language, but it was taking too long, and we realized, okay, it's not happening. Let's dive into the code. Whatever mistakes we will make, we'll let the compiler guide us how the language works. And one of the major things that worked in favor of us was Constantine is written in a very C-like syntax. Like it's written in Nim, but it's kind of organized in a very C-like manner. So since I am at least very comfortable in C. So even there was nitty-gritties of Nim. There were different aspects of Nim like macros and all that. But majorly, it kind of wasn't a pain. And with time, with compiler throwing errors everywhere, we kind of learned NIM. We didn't take the conventional approach of learning NIM from any tutorials or anything. We just dived into the code because, like, if you are good at with any language, picking up another language, I don't think it's very hard. So yeah, that's the approach that at least worked for me.
for me, I basically found myself writing a different kind of nim in every repository I came across. It became very like weird at the first, but like then I realized that these are like kind of coding practices centric to the repository. So when I started working in Constantine, as Advaita said, it's fully C based. It's a lot of snake casing functions. Okay, like it's completely looks completely like C, and yeah, I mean, you don't get to use, like MRATSIM didn't allow us to use even sequences which are like dynamic vectors. Okay, or like let's say if we want to do like something like slicing in Python or in any language, you just take like you just write it in square brackets and you just write the first index and the last index and dot dot less than or dot dot something like that. All those things were like kind of banned in us, like in Constantine, because he just didn't allow us to like these operations were centric to vectors and dynamically allocated arrays. And since we were always using static, we like wrote C like complete C like nim, where we used to always do and I and for j and then for k if you are writing a nested loop, and it looks bad, but it's fast because a lot of inferencing the compiler is not doing here. And if you're writing assembly, like if you have elliptic curve assembly like down there in the crypto system, it becomes very easy to pick up for the assembly level. it becomes very easy to pick up the tokens from the language and parse it accordingly. Otherwise, like it'll kind of keep resolving. If you like kind of write for column in columns, like you write like that, you like writing like a high level language. It's more difficult for the elliptic curve based assembler to pick up the tokens one by one. Like, what are you talking about? But if you write it in a complete C like manner, they are very like easy to. Yeah. Then when I came to then I came to Nimbus ETH1, and Nimbus ETH1 was kind of mixed nim. So some people wrote a lot of Rust-like nim where they have options as return types, where you say if this is some, then this or none, and you handle the error, which is like a very Rust-like nim. And yeah, you would have like very um, equivalent stuff like as of structs and types in Rust, like very coherent to each other. Types and type objects in nim and structs in Rust look very similar to each other. Yeah, but then when I came to Nimbus ETH2, now I'm working in the consensus layer. I realized that they have their own types, they have their own system. Everything is written by Nimbus itself. So, like, so what they wanted to do is they wanted to have the power of options, and they wanted exception handling at the same time. So they built a library called nim results, where you say that if this is okay, then I have handled the exception at the same time. I have got a value. How good are LLMs with relatively a new language like NIM? Actually, snake case. Okay, yeah. Um, I have seen a repository where a guy actually wrote Llama 2 in NIM, and it really benchmarks well. And I think there is a GitHub repo where Andrei Karpathy from OpenAI, he basically tags all the LLMs that have been implemented, like referencing his Llama C implementation. And I think he even featured there, like the NIM repo. And if you want to actually see, wait, I have a repo for you. One second. There is a repo called ArrayMancer by Emratsim again. This is basically NumPy, but in NIM. Yeah, it has very fast vector processing. It has matrix multiplication in the fastest of time complexities. So you can definitely play around with this. One cryptographic milestone that even we have for Constantine is um, having tensor processing. Plonky 3 has it, I guess, or I think they're working on it. But yeah, having tensor processing is definitely one thing. Like, yeah, before that you need to write like a lot of assembly, I guess. Yeah. So Nimbus ETH2 maintains its own libraries. Okay, so there is something called Nim Chronos, that is Nimbus's own proprietary, not proprietary obviously, is open source asynchronous runtime, which is like equivalent to, I guess, yeah, you have Tokyo and those things, right, in Rust. Yeah. Yeah, so those things are very Nimbus specific, and you won't find them in the Nim documentation, and you will initially suffer a lot, but eventually you will just get past all of that, and you'll realize that they are pretty powerful and pretty fast. Yeah. So there are like three stages of writing Nim, I would say. Yeah. Like where you write C like, then you write Rust like, and then you start using libraries from Nimbus. Yeah, that's pretty much.
Yeah, for us, like we didn't choose a language name. We kind of wanted to contribute to Workle, and the only project that was available in Workle was Nimbus. So we went ahead and learned Nim. It's not that we know Nim or we learned Nim. to contribute. Like that's why we contributed to Nimbus. It was the opposite. We wanted to contribute in Vorkal or some kind of cryptography, and the only cryptography related projects that we got interested in or we wanted to contribute was in NIM. So we learned NIM. So that's the reason why
Yeah.
NIM.
Addressing a few questions. Yeah. Pardon me for okay, how safe error-free is Workl implementation? Well, am I muted now? Okay. So in Constantine, there is like a proper framework of writing cryptography, and you won't get merged if you don't follow that framework in most cases. Like, you'll just be like reviewed and reviewed until your code improves. Firstly, that. So there are specific types, specific things that you need to follow. Safe and error-free is Workl implementation. Well, it is cross-checked with Nethermind, Go, and Rust Workl. Everything pretty much is cross-checked. We have cross-check commitments. We have cross-checked IPA. There is one edge case which came out very recently, which throws a bug in the IPA prover, but I think that has been tackled too, and that has been cross-checked as well. Um, how do you gauge your confidence level in the code? Well, see, the thing is, we don't really have like a really nice debugger, so we basically echo or we basically print at like checkpoints. But the thing is, the good thing is when you print at checkpoints, um, like you're very confident at least about the debugging process, because there are no caveats, right? You're just simply printing. You see what you see, and you can obviously like compare test vectors or vectors with other reference implementations. So let's say there is a spec by in Python by the EF, and they wrote the cryptography, and after so and so line, after so and so like crazy complicated operation, you expect a proof. The best thing would be to go ahead and cross check the proof. Is it consistent in your system or not while writing test suite? And the best thing I would say is, don't just write round trip tests like proving verification, because this is a mistake I did. Yeah. So NIM had like a kind of a buffer overflow, and it actually intrinsically overflowed the buffer while creating a proof. So what happened that the proof was erroneous, but at the same time the verifier was using the same overflowed buffer. So it thought that okay, the proof is right, and the verifier used to pass the test. And then until like I took test vectors from you might be knowing Ignacio. He works in EF. He has authored Go IPA, part of Go IPA, and he basically works at Geth and like the Verkle team for Geth. Yeah, he was with us in EPF3, and Ignacio was that time very helpful. He provided me like test vectors, kind of line by line, like first loop, these are the test vectors, second loop, these are the test vectors, and that is how you cross check. At least in Constantine, and I feel for writing cryptography, um, trust me, you would want to cross check. You might write excellent code. Yeah, yeah. You had a question.
Yeah, sorry to interrupt you again. But I'm just wondering, like test vectors and unit tests are fine enough, but what about side channel leakages? And it's just not timing leakages. You have other implementational leakages in cryptographic libraries. So is like Constantine already sufficiently peer reviewed and audited, or is it going through the process for it?
Okay.
It is going through the process of auditing and fuzzing. It's not yet audited, but yes, it is peer reviewed. And about side channel attacks, uh, like we with our implementations try our best to have everything in constant time so that it doesn't happen. Mami also reviews each and every PR, each and every. There are 4 or 5 guys maintaining it, including us, me and Agnish. So yeah, and obviously other people from status is also reviewing it. So yeah, it is peer reviewed, but about the audit process, we are on it, uh, but the audit process is still not completed.
Yeah, like another addition I would say is like a lot of very few basic operations, elliptical operations. We have a constant time variant to all of those things, even constant time MSMs. And the thing is that, like, let's say when you before us, you had constant time MSM implemented for, let's say, some other curve. Let's say you had it implemented for KZG. So like implementing constant time MSM wouldn't be too hard for bandwagon if you like kind of follow the constant time framework, how to make it constant time. And yeah, very very like low level operations are actually all constant time. About auditing, I think the KZG portions are all audited. It was audited last year, and that's why right now we are actually pushing forward for a release, so that we can basically start an audit, and from there onwards we like actually have further plans for Constantine as well. Like in future we would be happy to implement like post quantum stuff, or Stark, like all the Stark track, Baby Bear, Mersenne, all of that stuff, or FRI, all of that stuff. Yeah. What other questions? Gemini 125 Pro benchmarks any document pretty well. Yeah. Okay. That's the question. Uh,
Mhm.
I do. I do. Nimbus ETH2 is sort of, I would say, a bit understuffed if I compare to other sales, but I still do. It's when you write everything on your own, you do take a lot of code ownership. A lot of nights you lose sleep, but you would definitely enjoy. There is like a lot of people to help you around. If you get to know your peers, like people, other co-developers, like you will never feel out of place. So yeah, I mean, there was a time when okay, so right now at Nimbus ETH2, I'm the only one writing PRDAS for Nimbus ETH2, and we actually kind of started late. We started in May. However, like other clients, they kind of started in February, and I think it should take me around 2 more weeks to send it to DevNet. And yeah, I have been writing everything just on my own, and I've just been getting reviews from Tersek and all of the other people, like the senior people at Nimbus, and you would enjoy it. I don't think you won't. See, the thing about, I do agree, and I do see the point of, let's say, even contributing to layer twos. I would probably bring this topic a bit. Yeah, you will see in Twitter that so and so guy wrote so and so thing, and it is so and so faster, and everything looks cool. But the thing is, in Ethereum, in as a core developer, first and foremost, um, it is, you take time because you can't afford to be wrong. Layer 2, you can afford to be wrong. uh, yeah, so if you are having some experimental ZK VM, you can afford to be wrong. Yeah, but in Ethereum you genuinely can't. And I think you should, you should be like, this entire sense of responsibility kind of gives a thrill to it, that okay, maybe I'm contributing to something that's so big. Yeah, so I do enjoy working as a core developer, and I feel like, yeah, I'm pretty good, like at this, like pretty set at code development for now, and I think I'll stick for quite
Yeah,
some
I
time at
think
this.
I think I just
Yeah.
want to add one more thing. It's in code dev, it's more about the challenging problems that we can solve. Like the
Yeah.
problems are really, really interesting that we get to solve. So it's like a place that no other can offer.
Mhm.
And another thing is like your opinions are like you are free to give your ideas to any place you want to. So if you find that okay, this is something that is that you think might be less secure, or that you think that this can be more optimized, or this might not be the right way, you are free to give your ideas. And if people think that your idea is good enough, they're happy to accept it also. So this is also like a great
Yeah.
part of being a core developer, and which I really enjoy.
The other very beautiful thing about consensus and execution specs are a part of it is there, a part of it is peer reviewed, and it is common to every client, and uh, quite a bit of a part is completely creative. You can come up with your own solutions for that. So let's say when you're writing, like when you're implementing consensus specs somewhere, let's say for PeerDAS or let's say for Pectra or anything, there are types, there are functions that are definitely there which are kind of unavoidable. But let's say your RPC handler or your gossip protocol or how your libp2p works, or let's say how your database works, these things are all open challenges. How do you want them? And would it work fine for the client that you are designing based on your client's programming language? So a lot of things to be considered there. So it's a blend of specifications and creativity at the same time. So yeah, that is also there.
Yeah, that's awesome. Guys, thank you so much. We are already past the hour. Maybe if you have any more last, this is a great point to finish with. By the way, I think this was really nice, really beautiful last point. Advaita, maybe if you want to have some last comments, or Agnish, if you want to finish some last thought before we
Yeah,
wrap it up.
I guess we can take a brief 5-10 minutes ish. I guess if that's okay
Uh,
to run through the
so
projects.
I am. We are already out of time. I think we can. To be honest, I mean, I have to leave.
Okay.
Maybe if you want to stay and chat with
Mhm.
fellows, we could do that. But I have to run to another call, and also like guys, Advaita Agnishir are available in Discord.
Yeah, yeah.
We can open a thread there. I will take you in a thread, and you
We
can
can
ask
do
your
that. Yeah, we
questions
can do that.
there. So if you
Yes.
have any follow up
Yeah, any of
questions,
the fellows who feel like contributing to Nimbus can also DM us in the Nimbus. You can join the Nimbus Discord. There's a specific channel made for EPF right now, so you can also talk there. You can also ping or tag us in the Protocol Fellowship in EF Discord. So yeah, just reach out to us. We will be happy to help.
yeah,
Yeah, and
awesome.
I've left my Discord and Telegram. Anytime, anybody, any issue. Yeah.
Mhm.
Yeah, awesome. Yeah, I will create the thread. And by the way, like kudos to like Nimbus is doing a great thing that like some of the clients, including Nimbus, have this contributor or even EPF specific channel, which is really great. So,
Yeah, we
uh,
we got it up few days ago.
Yeah, we got it up because we were getting a lot of like people texting us, and we okay, it's getting difficult to manage. Let's have a channel.
that's awesome. Yeah, that's really great, guys. Yeah, thank you so much for your time, both of you. I really appreciate it. I mean, this is like you guys are an example of not just like the successful follows, but just a year ago, these two guys were exactly in your shoes. All of these follows, and I think what it demonstrates is like all of these core devs, all of the people here, the mentors, like they are your peers, they're your colleagues, right? Like we always say like don't bother mentors too much, they are busy and so on, but not from the authority perspective, but from like the respect to your colleagues, to your peers. So it really gives me this vibe of like yeah we work together as peers. And yeah, I think we can wrap it up here. Open the Discord. Yeah, again, thank you so
Yeah,
much, man. Agnish, I hear the honking from the street all the time. I have such a Indian vibes. After this, I need to get some Indian food. Like I want to get like
you need to
total.
come to India.
I have such
Don't
Indian
just don't
vibes
just
after
stop at
this.
Indian food. You need to come to India.
Yeah. I need to get some proper one. Yeah. Again, thank you so much. I really appreciate your time, and it's especially because it's late there, right? Yeah, I appreciate it a
Yeah,
lot, and yeah, wish you all the luck with the great work on Nimbus. Keep it up, guys, and I hope to see you at some of these conferences where you can meet fellows as well. But
yeah.
soonest I'll see you in the
Mhm.
Discord. So yeah, see you there.
So yeah, we're definitely coming to DevCon. Uh,
Yeah,
Definitely see you at
DefCon we are
DevCon.
coming.
ECC not so sure, but yeah.
Yeah, awesome. So thank you guys again, and have a great day. Have a good day, everyone.